Back to the Revolution in Intelligence Affairs colloquium. Um, we have already had a cameo appearance of our next speaker, Dean Souleles. It is my honor to introduce him. Currently in private practice at Ginosko Consulting, he was formerly the director of Intelligence Community's Artificial Intelligence Innovation Center, and also the chief technology advisor at the ODNI. Prior to that, he served as the chief technology officer of the National Counterintelligence and Security Center. He had an earlier career as an executive of companies involved in healthcare information technology and began his career at NASA's Jet Propulsion Laboratory. Mr. Souleles earned a bachelor's degree in computer science from California State University at Northridge. And his talk today is called entitled Augmenting Intelligence, the Future of AI in the IC. Thank you, Dean, for joining us today.
Well, thank you so much, Joe. I really appreciate it, and thanks for the opportunity to be here. I have to correct the record, though, before we move forward. I am of the generation of computer technologists that started the university but never completed.
I see. Okay.
I was working for Hughes Aircraft, Litton Industries, and eventually NASA's Jet Propulsion Laboratory while still going to school. And eventually, at a time when computer science was evolving so rapidly that the work I was doing far eclipsed anything we were being taught in school, and I eventually left it behind. So that's a common mistake. That's why my resume says educated in computer science. I make sure to make that point. No false claims of credentials here, particularly in an august body as the National Academy. Thank you again for having me join this colloquium today. And Anthony, thank you so much for reaching out to me and asking me to participate in putting the panel together. What a terrific panel and terrific opportunity. And this particular forum, being a public forum discussing the U.S. intelligence community, is terrific because so much of what the U.S. intelligence community does of necessity is conducted in the shadows for understandable reasons. But there is still so much for us to talk about. I'm also reminded of the challenge of following a deep thinker like Anthony and a broad thinker like Director Cardillo, and then being sandwiched between them and the Army mad scientist, Luke, who's coming up in a little bit. So that gives me a little bit of a challenge for things to talk about. I have the Q&A open, and I'm happy to take questions kind of as we go. I have a number of things that I wanted to discuss with you, but I'm also willing to take this any way that you would like it to go for the participants. I miss being able to do this interactively. I quite enjoy being able to have a dialogue. So wherever we want to go, we can go. So Anthony said something really interesting kind of in the last little Q&A session. He said Google is a part of his thinking. Now, whether or not you like the results that Google does, or whether or not you think Google's algorithms are working, there's a key idea there that I want to hit on in this conversation. And that idea goes to the future of AI in the intelligence community and the way the U.S. intelligence community will use AI and the way AI will be deployed throughout the community going forward. And that is increasingly going to be in the context of developing what we think of as a joint cognitive system, where the artificial intelligence or the computer system behaves as part of a joint system with the human operators and analysts. Today, we treat computers as tools. We ask them questions. We do searches. We ask them to do computation. Virtually all of the problems we ask computers to solve can be reduced to that kind of search idea, and where we're basically instructing the computer to do a thing for us. And in some ways they anticipate and they do some recommending and things like that. But rarely do we think of the the systems as a joint system where the human and the computer are acting jointly. So I want to talk a little bit about that as we move forward. But before I do that, I want to back up a little bit, because there has been a tremendous growth in the technological acuity of our community in just the last few years. When I was asked by Principal Deputy Director Gordon to lead the AIM initiative, she had just come from NGA working with Robert, and they had commissioned a study that famously now concluded that if we didn't change the course and speed of the way we did geospatial intelligence analysis, sometime in the next decade, we would need 8 million imagery analysts to do the work for the people that we have today. That's a really striking image coming from the director of the National Geospatial Intelligence Agency, and it talks about the problem of the overwhelming amount of data that we collect and the world generates. This replicates itself broadly across the U.S. intelligence community. You know, if your job at NSA is to monitor every fish in the ocean, but only look for those that are important, you get a sense of what we're talking about. In fact, it's worse than that. You have to identify a particular fish, but because it's foreign intelligence and because of all the rules of privacy and civil liberties that Robert discussed, you have to eliminate all the other fish that look exactly and behave exactly and are swimming in exactly the same water as the fish you're interested in, so that you don't get sideways with our civil liberties and privacy. And that's, in essence, the job of the National Security Agency. Enormously complex, and the amount of data that we need to look at in the signals that the world produces is unfathomably large. You cannot get it in your head. You can look across the community and say open source. Both Robert and Anthony mentioned the importance of open source intelligence. Just imagine for a moment that your job is no less than to read every newspaper in every language every day, and watch every news program in every language on every television station every day, and monitor all foreign social media that might be of any relevance to intelligence every single day, and from that pick out those things that are important to look at. That's the job of open source intelligence. And then from that produce conclusions that can help inform our national security states. Think it just, if you get your head around the size of that problem, and this is all before the advent of 5G and the Internet of Things and the massive proliferation of data that is coming from those things and the massive fully instrumented world that both Robert and Anthony talked about. That's where we sat in 2017. NGA had just started its AAA initiative, but there was no national initiative. Remember this, there was no national initiative for artificial intelligence in 2017. Not a single agency of the federal government had a strategy for AI. The Department of Defense did not have a strategy for AI. The U.S. intelligence community did not have a strategy for AI. The Department of Energy did not have a strategy for AI. The Chief Technology Office in the White House wasn't even thinking about it yet. That's where we started, and that's just a few years ago. So now we're able to have this robust conversation where the playing field has been leveled to a degree. I mean, it used to be I would go into the meeting and I would be the only one among the group that would be able to describe what a deep learning neural network was, or how reinforcement learning worked, or what adversarial machine learning was. In fact, when I briefed the Intelligence Community Studies Board at that time, the conversation was more about, these are not the drones you're looking for. This is not what AI is. It's not that science fiction-y sort of thing. It is exactly the opposite of that, actually. It's a set of statistical predictive analytics that in many ways go back to the 1950s, when we had this idea that you could combine computer logic in the way that we thought brains work with these neural interconnections and these artificial neural networks. So the conversation has grown tremendously since then, and I'm delighted to have an opportunity like this to kind of think about, all right, as we begin to adopt these technologies, where do we go, and what's next? So we now have a strategy for AI emanating out of the White House. We have a strategy in the U.S. intelligence community. The Department of Defense has a strategy. Many of the other federal agencies are moving out. The National Security Commission on Artificial Intelligence just released its report. It made a big push towards this need to develop justified confidence in artificial intelligence. Robert hit on that a little bit in his remarks. This idea, and so did Anthony, this idea that if we are going to acknowledge that AI-driven systems are going to be increasingly a part of our day-to-day dialogue and existence, we better understand how they work, and we better have confidence in their ability to work. Anthony gave a tour de force kind of walk through the potential future of intelligence across the agency. So I'm not gonna repeat that, but I am gonna observe that the needs of the national strategic needs of artificial intelligence are indeed different than the DoD and kinetic needs. And even within the intelligence community, there are differences in the kinds of questions that we're trying to answer and how we would use the technology. I had the very good fortune early on in my intelligence career, which I came into already as a senior technologist, to work with Robert on what we call the mission user group for the IC's information technology enterprise. And the concept behind the mission user group was to bring the customers of the technology together to discuss what they wanted from the technology, rather than to have the technologists provide technology to the customers and say, well, here, use it. I think this will work for you. And we would have very energetic debates at our mission user group meeting, because one of the co-chairs of the group was Kathy Johnston, who was at the time the director of analysis at DIA. She was very concerned at that point, as we are today, about what's going on in South China Sea, and what islands is China building, and where are the ships going. And Robert, who was the president's briefer, commented famously to her one day that he knew that she was very concerned with bright, shiny metal objects that you could see from space. But what he was worried about is, are we going to war with China? And there you have, at the very top of the U.S. intelligence community, two very distinct views of the kind of questions that we have to answer. And the data that feeds those questions is enormously different, right? So if you want to track ships in the South China Sea, then satellite imagery and signals intelligence is your friend. It's you have ubiquitous pictures of the world taken 24 hours a day, commercial and national technical means, and you have the ability to track through electronic signals where big things are and where they go and how they move. If you want to know what are the leaders of China thinking, that's a very different topic. And where does that information come from? And often it comes from just our, turn off the phone here, apologies. Often it comes from open source media and reporting and what people are saying and how they're talking, or social media, or how people are feeling, or what the sentiment is in other parts of the world, and what people are thinking. And it requires human judgment in order to make those assessments. Computers are very, very good at answering questions like how many, and where, and what, and that sort of thing. In other words, they're really, really good at those kind of that's kind of data crunching and analysis. And sometimes they're better than human, right? So geospatial intelligence, if your job is to look at satellite images every day and count airplanes on runways, which is what many geospatial analysts have done for years, particularly specific runways where specific airplanes might be. We want the computers to help you do that better and faster, and take away the drudgery of counting the airplanes on runways every single day. Instead, as an analyst, we want you thinking about why there are less airplanes on the runways today than there were yesterday, and where they're where they have gone, and what are the intentions of the people that decided to move those airplanes. Another example is if you're looking at geopolitical events like the Arab Spring, a question you might want to ask was, well, could we have predicted it? And more importantly, what's going to happen the next time? Another question that Robert famously asked in one of our mug meetings: if the Jordanian monarchy falls, and then what are the geopolitical repercussions of that? This is not something that the AI can help you, and this is where I might differ with Anthony a little bit, in that I think that the human analyst in the loop, on the loop, in control of strategic intelligence is key, because it's judgment at the end of the day. It's about taking in the set of information and data from these broad sources and turning it into something that is a judgment call, that is a recommendation, that is informed by geopolitical analysis. Many of our analysts are political scientists and economists and social scientists and these sorts of things. And what they know is they understand human behavior, and they know how to take the data that comes from the algorithms and turn it into analysis that then can be digested by our national leadership. So those are kind of big concepts behind where I think we need to go with where I think we are going to go with artificial intelligence in the U.S. Intelligence community. Our initial questions that we asked when we started AIM were those questions of who and what and where and when, but not how or why or what if. We didn't ask those questions. And we know that AI is very good at pixel peeping, counting cars in parking lots or airplanes on runways, and really bad sometimes at what specific airplane is it, or which needle in the pile of needles are we interested in, or why fewer airplanes today than yesterday, as I said, or what's going to happen next. Now, AI applies broadly to all aspects of the U.S. intelligence community, not just the collection and analysis aspect of it, but to finance. So as I would go around and talk to our chief financial officers, they both needed to understand AI, but they also wanted to understand how they could use AI to better understand the intelligence community's budget and how we use resources. The general counsels of the AI similarly were interested in what does it mean about their oversight responsibility, and what protection should we be putting into our contracts as we write contracts, and what should we be requiring of our people. The inspector generals of the intelligence community similarly were, how can we use AI? What do we need to know about it, and how can we use it to do a better job of overseeing our community? So all of these areas can use AI, but those are not the areas I really want to focus on. The areas I want to focus on are the mission areas. And I want to get to this idea of a joint cognitive system. And the idea here is that the computer and the human share the cognitive load. The computer relieves the human of the cognitive challenges that the computer can handle better: massive data summarization, finding the unique needle in the haystack, making way for humans to deal with the higher level cognitive tasks of assessment, context, meaning, and judgment. That's what humans do: context, meaning, and judgment. And the AI of the future will increasingly be part of a system. As Anthony said, he doesn't memorize things anymore. He talks to Google, and Google helps him remember things. Well, imagine a world where the analyst in a joint cognitive system does their work. They ask questions, they look for data, they begin to form judgments, begin to form assessments. All the while, the AI-enabled backend is paying attention to what the analyst is doing, is paying attention to what the group of similarly related analysts are doing, and beginning to form alternative hypotheses and collect data that is relevant to the thing that the analyst is interested in, or maybe is tangential to what the analyst is interested in, but we know that there's a connection that might be of interest. And without the analyst having to do another search or a query, the data or the information is served up in a way just in time, at the right time, while the analyst needs it, in this sort of a joint cognitive way, so that you're no longer thinking of the computer as a separate entity from the cognitive system that includes the human, because they're increasingly integrated into a single system. Similarly to Anthony never remembering things, I don't open maps anymore. I just ask the AI-enabled mapping systems to help me get from point A to point B, and I develop confidence that they're going to make the adjustments. And with systems like Waze, they even take into account real-time incoming traffic incidents and route me around to find the best possible route. It's a joint system. I'm still driving the car. I'm not in a self-driving Tesla yet, but I'm using increasingly parts of the technology in order to in order to navigate. So there's a question in the chat says, in some respects, we've been talking about this stuff for decades. How do we stop the talk and accelerate the engagement and solution development between government, industry, and academia? So that is a key theme that I've been trying to emphasize during my time in government and since then, is that just as I described before, government is slow and the private sector is fast. We have a different risk calculus, and we need to find ways for government to go faster. And there are things that government can do to go faster. One of the things that government can do is to start smaller and build on success. Private companies do this all the time. Very rarely does a private company engage in big bang type thinking these days, where you invest many millions or hundreds of millions of dollars into a technology or a system before you've demonstrated it has viability. And in fact, Amazon is famous for their 2 pizza teams, where every idea starts out with a group of people that can fit in one room and be fed by 2 pizzas. And that's a key idea. We don't do that often in government. We should do that. We should do that more. So the idea that government can't go fast, I think, is false. I think government can go fast, and we both in the Department of Defense, initially with Project Maven, and later with the Joint AI Center, and in the USIC with the AIM initiative, we demonstrated that there are some ways to do that. But we need the regulatory bureaucracy of the government to catch up. We need the much sought after acquisition reform. We need to be able to push decision making further down the chain. We need to allow government officials in reasonably responsible positions to make acquisition decisions without the entire bureaucracy of the federal government coming into play. We need to kind of dial back on some of the well-intentioned rules that are put in place to prevent malfeasance, and in fact, start using AI and other related systems excuse me, to track our acquisitions and to make sure that we're staying within the guidelines. There's a different way to do things than we have been doing things. All right, there's a question about in the chat about human cognitive systems and what are the risks of cognitive bias, e.g. confirmation bias, and do we see emerging? This is a really important question. Bias in systems is inherent in all analytical systems. We make biased decisions when we decide what data to collect. We make biased decisions when we decide which questions to ask of that data. The important thing about bias in our systems is that we understand and characterize those biases, and that we have a way to think about those. One of the things that we did not have and still do not have to this day is a robust decision raiser for have we properly accounted for the biases in our system. Where civil liberties and privacy community normally comes down on this question is they use the civil liberties term of bias in a way that data scientists do not. They often mean bias that is going to deny some protected class some benefit. And we all don't want that kind of bias in our systems, particularly when we're dealing with making loan decisions or whether the government should give aid or not. Those are the kind of biases that we want to avoid. My point was all systems have bias, and we need to understand and characterize those biases so that when we use systems, we are using them for the purpose that they were built, so that they actually answer the questions that we want them to answer. Project Maven famously had a problem early on in that all of their algorithms were developed over dry spots in the world, the desert. And when they took the same algorithms and tried to deploy them over the jungle, no surprise to a data scientist and an AI analyst, they didn't work because the data was biased towards a different area of the world than they were interested in. So this area of bias is really strong. Now, to get to the specific question, we think that if the AI and the analytic systems are built properly, they're going to help counter cognitive bias of the human. In other words, the human has a set of biases based on the way they're thinking, and the AI-driven systems can provide alternative hypotheses that the human may not see because of the preponderance of data. Because the amount of data is so overwhelming, the human tends to narrow in and focus and doesn't often have the ability to see all the tentacles and see all the interconnections. So we think that if we build our systems properly, we can counter that cognitive bias by having the computer always suggesting alternative hypotheses. Have you considered? Now, a recommender system from Amazon is kind of like that. It says, people who bought this often buy this sort of thing. Have you thought about that? But that's really primitive. What I'm talking about is, you're thinking about these 3 or 4 or 5 big topics. Here are 3 other topics that you may not have considered related that we know are related because there's data network interchange between these sorts of things. That's what I mean by this alternative hypothesis view. And we think that the future of AI is that in this joint cognitive world, the AI is constantly participating in this dialogue with the human analyst and actually moving us back and forth. All right, we have another question. What would you do after an adversary captures acquires your hypothetical AI, e.g. a captured US drone and crudely copied it? Okay, so now we're getting into a different kind of territory, and this is the difference between deployed autonomous systems and strategic systems. I don't think there's a high likelihood of an adversary capturing the kind of system I just described, but on the other hand, adversaries capture physical things all the time. And in fact, they're going out of their way to try and capture our physical things, and they're going out of their way to try and influence our systems and create problems in our systems. So hardening the systems, obviously making sure that they're not vulnerable to reverse engineering will go so far, but our own experience is that if we get our hands on the device, we can pretty well figure out what the device does and how it works eventually. And nation states who attempt to do that against us are well financed and will spend virtually any amount of money to do so. So it's really, really important that we apply our defenses in depth and we make sure that we're creating the defensive lines where they need to be to protect the technology. I actually think the far greater risk is that our systems get spoofed in ways that we don't understand, because the current state of AI is that it is quite vulnerable to adversarial attack and adversarial machine learning, and the idea that systems can be poisoned with scattering just a little bit of digital dust in them. If you know a little more about the systems that are working, you can get them to hallucinate. You can find lots of images and examples. If you look at Stanford and other universities who spend some time on adversarial AI, and you can see where there's a famous one out there of the elephant in the room, where somebody actually put an elephant in a living room, and the AI, the computer vision went crazy, couldn't recognize anything else because the elephant was essentially causing the neural network to go insane. We've demonstrated that you can get AI to hallucinate, see things that aren't there, and misidentify things that are there. So that's the kind of concern I'm worried about, which is how do we protect our systems from those kind of attacks, and how do we make our systems more robust? This gets back to the National Security Commission on AI and their guidance to all of us that we need to focus heavily on developing justified confidence in artificial intelligence. Justified confidence is a really good term because it means, how do we know that it works? How do we know that it's reliable? How do we know what the boundaries are, where it can be used and where it can't be used? How do we know where we should never use it? Those are all the things that go into that, in addition to how can we explain the conclusions that it comes to. So, Robert talked about, what the presidential daily brief was like. I often think about what an intelligence report reads like. So if you've ever read a human intelligence report, it reads kind of like this. A known source who has previously provided us reliable information tells us X, and therefore we believe Y within this range of possibilities. There's a lot in that. If you unpack that, a known source, it's somebody we know, we have confidence in. Who has confidence in them? Well, our officer has confidence in them because they've talked to them and they've spent time with them and they've developed a relationship with them. And by the way, they've previously provided us reliable information. We've checked off the box that says they're a consistent and reliable behavior. And they told us a thing. And we put that thing in the context of all the other things that we know, and we applied a probability matrix to it. And we said, we think with high, low, or maximum probability, this is the likely outcome. You can explain that to the President of the United States if it comes down to it. You can say, here's how we got to our conclusion. What are you going to do when your conclusion is the hidden layer of the neural network, the reward function went from X to Y, and therefore we got to this conclusion? Not a satisfying answer. So developing ways of talking about how these systems work, what they do, how they get their conclusions is the task that we have at hand right now so that we can make them more explainable and understandable. At the end of the day, we would like these systems to be as reliable as our electric grid. And what I mean by that is when I walk into a room and I turn on the switch, I expect that the lights are going to come on, but I do not have to know as an end user consumer how the power plant is constructed and how the electricity gets from the power plant into my room to my light bulb. But somebody has to know that, and I have to have confidence that the somebodies that know what they're doing and have done the work. And so we, as part of the U.S. Intelligence Committee working with the DoD, began development while I was still there of a maturity model for artificial intelligence. How should we begin to think about these kinds of questions? And I think that's really, really important. Let's see. Another question. How do we obtain enough data to train out bias and IC models regarding non-foreign persons and non-criminals, terrorists? Do we partner with commercial entities? If so, do we step the risk for potentially poisoned data models? That's a huge question and a really complicated one. I don't have a great answer for it, other than to tell you that the job of our data scientists today is to sort through where we have gaps in data and figure out what data we need. Now, the good news about working for the U.S. intelligence community is a big chunk of what we do is collect data. And so if we don't, data scientists like working with us because they can often come back and say, well, if I had this data, I could better answer the question. Well, we go get that data. That's what much of intelligence does. It collects data. And so figuring out what data to collect in a way that influences that conversation is really key. So how do we go about figuring out what data is going to be important and what data is not going to be important, and how do we characterize bias? And that's this recurring theme: understanding what data we have, what data we don't have, what's missing from our data is key to making these things effective. Again, getting back to this idea of a joint cognitive system, the joint cognitive system should be looking continuously for the gaps in the data. Where is it that we do not have sufficient information to make the inferences that we're making? And that should be alerting that to the analyst that you're making an inference for which there is no data to support it. And then the analyst has to come back to judgment. But that judgment has to come through in the final intelligence report saying, here's what I believe and here's why I believe it. Let me see what else we have. To what extent are congressional appropriations and budget cycles the greatest limiting factor to using minimum viable product framework to deliver new technology? Almost everything needs to be a program of record. That is obviously written by someone who works in the government, who deals with this every single day. And I agree, that is a challenge. And it is what I meant when I say we need to focus on acquisition reform in a way that gets us away from large programs of record and increasingly towards incremental systems and systems of systems. Now, in the intelligence community, the move to cloud technology took us a long way to do that, because many things that we build right now are built from components in the cloud that in a previous generation would have been a large procurement, which required an RFI and then an RFP and then an industry day and then a proposal and then a contract, and then 5 years later getting a system that was built in a data center that somebody built from us with a bunch of contractors that didn't actually solve the problem that we had today, but it might have addressed the problem we thought we had 5 years ago. Well, we're doing less of that. We still do too much of it in my view, but it is one of those areas where I think we need to continue to work and continue to focus on, because unless we can operate at the speed of the internet and the speed of industry, government stands the risk of falling further and further behind. And our adversaries famously do not have all the same restrictions that we do. But having said that, I want to make a point that didn't come up in the chat. I'm often asked about this data question, and they say, well, isn't the real problem that China has all the data and we don't have the data, so we just need to get more data? And my answer to that actually is surprising to people, and which is, I actually don't care how much data they have, because I know how difficult it is to manage all that data. So let's just assume for a moment that you actually have the ability to live stream all media all over the world, all over the time, and all 5G all over the time. Where are you going to store it? Where are the data centers that are big enough to store it? If you manage to store it, how are you going to index it? If you manage to index it, how are you going to retrieve it? How are you going to get it to the people that you know what to? And by the way, in all of that data, how are you possibly going to know what is relevant and useful? That, in essence, is what we say, what I think some of our politicians think when they say, well, China has all the data, our job is just to go get more data. We actually used to think in the US intelligence community that all we needed was more data, and then we'd have the answer to the problems that we needed to answer. What we found out is we got the data, and we still couldn't come up with the answers, because it was understanding the data and interpreting the data that was key. All right, so with OSINT becoming more relevant and with the availability of data as opposed to classified data, would the IC be willing to direct OSINT gathering and classification to third parties, or is data all gathered and processed internally? So there are a number of non-governmental unclassified entities that regularly produce intelligence from open source data. CSAT at Georgetown is one of the big ones here locally, and I can tell you that the U.S. government intelligence agencies consume that sort of open source intelligence. With all open source intelligence, you have to ask the question, but you actually have to ask the question of classified intelligence as well, is what's the provenance of the data? How do I know that I'm not being spoofed? How do I know that I'm not part of that I'm not being susceptible to an influence operation and just recycling the message that some foreign government wants to inject into our system? So those are some of the challenges that we deal with. But I think there is increasingly a role for private entities to produce open source related intelligence. All right, so I think my time is just about up. So I thank you for the time. I think we're going to move to the next presentation, and I'll be back for the Q&A in the panel. So thanks so much. Back to you, Joe.
Thank you, Dean, for that very insightful and sobering view on the modern applications of artificial intelligence.